So I'm Hakan. I work as a solutions architect at Arize AI. And we actually had a company hackathon. I built like a multi-modal RAG application over there. So what I did is I basically built a RAG application over YouTube video where you ask the questions and from the video it provides an answer. So what I want to do is I want to kind of walk you through the process of some issues I have run into and how I solved them today. And it's going to be basically focused on the tracing and innovation of this application. But yeah, let's get started. This doesn't work. Okay. So first of all, when you look at the future of AI, or even AI at its current state, you can see that the number of multi-modal applications or use cases is growing like crazy, right? All the big LLM players out there, like people like OpenAI, Anthropic, or someone like Google, they're investing most of their time and efforts into building or improving large multi-modal models. And as these kind of models improve over time, the number of AI teams adopting these multi-modal models and applications also grows. And as that number grows, there is actually kind of some specific issues that might come up in order to kind of put those applications into production. And mainly, one of the common issues we see is that a transition from a quick and unique demo to a real product is not that easy, right? If you use something like LangChain or Llama Index, it is easy to create an application with a couple lines of code, like a multi-modal application. But it is not that easy to actually transition from that and to actually a new product that can serve to a large number of users. So what I want to do today is actually basically explain what are some open source tools and methodologies we can use so that this transition is not as hard as it sounds. And in order to do that, I'm going to actually focus on one single pain today, where it is the fact that even very small change in your application can cause drastic outcomes and performance regressions. So imagine you're building a Gen AI application, right? So you have a Gen AI application in place, you want to change the model, you want to change the prompt, or you want to change your retrieval strategy, right? So a very common use case is everybody was using GPT-4, then they tried to switch to GPT-4o, and then everything broke. Or it actually happened in our company as well when we were using the Copilot, right? So as you make these changes and ship it, a lot of stuff can happen. It can break the customer experience. It can lead to more hallucinations. It might work for a specific use case when you tested it, but it might no longer work for another use case. So again, these small changes that you make and the downstream effects of them can really compound over time. And this is obviously the biggest pain that we see in all the AI teams we work with today. And the main solution that we provide as a best practice is what we call an evaluation-driven development. So for those of you who worked in software engineering before, there's this concept called test-driven development, right? So where you actually have to write a lot of continuous tests before you write the actual code itself. And then as you ship those code changes, you still have to continue to do those tests. So in the case of Gen AI, we basically propose an evaluation-driven development, so something called EDD, where the main idea is you actually curate a data set, right? So you have a data set of examples, right? This could be a golden set of examples. This could be an example of bad data set, let's say a data set of hallucinated examples. And then what you do is you track your changes as an experiment on top of that data set. So let's say you change a prompt, right? You run that new prompt on top of your data set, and then you evaluate the experiment that you just run so that you can quantify the change you made to your application, right? And as you make these changes quantifiable, then you can actually track the downstream effects and then kind of prevent them over time. So the main idea here is to build some sort of iterative process around it. So I'm going to kind of go through how to do this for a RAG application, but let's start with a simple one, right? Let's start with a RAG application for a single modality, where we basically have a text-only RAG application here. So it's very simple. We have the user question coming in that gets turned into an embedding. Then it goes through the search and retrieval workflow, and then you have a prompt with the context and user question, which gets fed into an LLM. And then you provide a response. So on top of this architecture, how do we do EDD, right? How do we do evaluation-driven development? But first, we have to turn on the evaluation part, right? So how do you actually evaluate this application? So I'm pretty sure some of you are familiar with this, but just want to give a bit of context on LLM evals, where the concept that we call is LLM as a judge, right? Where you actually leverage another LLM to evaluate your current system under test. So you basically take an input and output of your system, provide it to an evaluation library. This could be Phoenix evals, this could be Gamma Index evals package, and then at the end you leverage another LLM to do that evaluation, and then the criteria for evaluation is defined in the eval template here. So at the end, by using this workflow, you can actually evaluate your system for any task that you want, right? And then you can do that quantifiable experiments and quantify the change that you do. So let's look at an example. So let's say you have a RAG application, you want to evaluate the retrieval performance, right? So what you want to do is like you have your retriever span, where you have the retriever inputs and outputs, and you provide that to, let's say, Phoenix. So we have this eval template here that basically compares the user question and the reference text together to check if the reference text is even relevant to the question. And if it is, that means that your retrieval worked, right? So by doing this on all your retrieval steps, you can actually quantify the performance of your retrieval. And the way you do this is like, let's say you made a change to your retrieval strategy, right? So if you made it, like, let's say you change your chunking strategy, you switch to another vector DB, or you try to do something else. And by doing this retrieval evaluation, you can actually quantify that change specifically for retrieval. But when it comes to a RAG application with a single modality, there are actually two types of evaluations, right? So first one is we just described, which is the relevancy evaluation. So here you're trying to understand, is the retrieve context relevant to user query? Where the second type of evaluation is the response evaluation, where you can check hallucination and correctness, right? Hallucination checks, is the response hallucinated based on the reference context? And the correctness checks, like based on everything, is it actually correct, right? Given the reference text, given the input and output, is it even correct? So we basically recommend that you actually start with these three metrics as a starting point: relevancy, Q&A correctness, and hallucination for any type of RAG application. Right? So this was an application with a single modality. Now let's try to go a bit more complex. So let's look at a multi-modal RAG application, right? The general idea is actually very simple here. You still have the same architecture, nothing changed. The thing that changes, the user query, the context, and response can include multiple modalities. So they can include stuff like audio, image, and text together. So let's say like in your vector store, you actually have multiple modalities. In the case of YouTube videos, we will have multiple modalities. So then you need to basically store your text and image data under separate collection of indexes, where you have a text embedding and an image embedding, and then your generative model should also handle multimodality, right? So it should be a large multimodal model, something like GPT-4 Vision, GPT-4o, etc. So if you want to evaluate this multimodal application, again, it's very simple, right? The main difference in this case is there are separate modalities. And you really want to quantify the changes on these separate and combined modalities as well. So let's say you want to check relevance, right? Relevance evaluation. You really want to understand, first of all, is your retriever working for your text embeddings? Is your retriever working for image embeddings? And is your retriever even relevant when they're combined as a whole? Right? So let's say I asked a question about YouTube video, which I'll show today. It retrieves some context from the text. That looks fine, but the images did not work, right? So maybe I need to focus on improving my image relevancy, image retrieval as a strategy. Or in the case of hallucination, right? You need to make sure that both modalities are combined to check for hallucination. Because let's say the text answers half of the question and the image answers the remaining half of the question. So when they are both combined, maybe then they actually answer the question itself. So it is important to evaluate these modalities individually and also combined as well. So what I want to do today is I'm going to show a quick demo video here. So again, I build a multi-modal RAG engine over YouTube videos. We have a bunch of YouTube videos of Arize onboarding. I took 20 of them, and then I'm going to show the architecture in a sec. And then I use Arize Phoenix to evaluate and trace this application. For multi-modal evals, I actually use Gamma Index evals. Gamma Index has a great evals package on multi-modality. And then what I'm going to do is I'm going to show you how that evaluation-driven work works using Arize Phoenix. So again, we have the same architecture. Just want to kind of explain how I made this work. So the main idea is we have all these video comments, right? So what I did is I first extracted the frames of this video. Like let's say every 5 seconds, extract the frames. Then I also extracted the audio, right? And then transcribed that audio into text so that we have a transcription. So that for each video, I have a bunch of frames and a bunch of text. And I have like multiple videos. So then what I did is I built a vector store that has separate corrections, that has an image embedding correction and a text embedding correction, so that whenever a user asks a question, it retrieves the relevant transcription and it also retrieves the relevant frame and see if it can actually respond to that question. So let's actually kind of look at the demo video here. Make this bigger. Okay, I think we're good. So what you see here again is Phoenix. Like Jerry just talked about it. This is your tracing page. It's an open source tool. We now have the hosted version of it. And the first thing that you see here is like you have the inputs, the outputs, and the evaluations, right? So the inputs are basically the user questions, and then the outputs are basically the response of the RAG application about that question on YouTube video, and then you have the different types of evaluations. So for the demo, I just focused on 3 metrics. I focused on text hallucination, text correctness, and then multi-modal faithfulness in the Llama index package, which again checks RAG hallucination. So what I want to do is like, I want to go through some examples, right? To basically see if my multi-modal application is working, find some interesting examples, and iterate, right? So what I'm going to do now is like here, I checked all my inputs and outputs. I have access to literally all the questions I asked. So all my interactions are already recorded in this interface. And let's look at an example, right? So in an example, the user asked, I want to create a dashboard to track hallucination rate by different prompt templates on Arize. How do I do this, right? And first, you can actually see the steps behind the scenes in order to make this possible. I use the most simple instrumentation here, where you can see the retrieval and the different LLM calls that actually provided this output, right? To create a dashboard, you have to do this, right? So this all looks good. And let's actually look at the evaluations. If I look at my evaluations, I see that it is correct, it is factual, and it is faithful. So this is actually a good example where everything works. And we have an explanation here that says like, okay, it compares the reference text, the input and output by using another LLM. And it basically says the answer correctly and fully addresses the question based on the reference text. So again, this is actually a great example. And if I check my retrieved documents, I can see that I retrieved a text, I retrieved an image, right? And then let's actually look at what that image is. Actually, as of today, you can actually see this image on on Phoenix. I just didn't have it when I recorded the demo video, but you will actually be able to see the image on the Phoenix interface as well. But let's look at what this image is that was retrieved, right? So we have this image from one of the YouTube video frames. And this is exactly answers the question. You actually have a dashboard here that checks hallucination by prompt template. So my retrieval worked really good. I asked a question, I want to track hallucination rate by different prompt templates, and it retrieved that exact frame where our co-founder is talking on how to build that, right? Again, I'm starting with a golden example first. And then it actually worked really well for this exact example, and it retrieved the right image and the right text. So what we can do is like, let's get a different example at this point, right? So let's go back to the Phoenix interface. And then let's try to check out another example. So the next example is an interesting one. What is the correct choice for Arize platform team? Right? So if we are asking specifically something visual, what is the correct choice? Right? And then you can see that the correct choice, it said it is dark blue and pink. Right? So I don't think in my text, I talk about the correct choice, but let's actually figure that out together, right? The output says it is dark blue and pink, which is correct, but let's see how it actually found that out, right? So if I go back to my evaluations, I see that my text correctness and my text hallucination is incorrect and hallucination, right? So it's saying that I don't have any text reference, text context to answer this question, which is about the correct choice of Arize. But my faithfulness says this is faithful. My multi-modal faithfulness says it's faithful. So that means that if I check my retrieved documents, I will actually see that the image that I retrieved is an image of Arize, and which got that dark blue and pink interface. So the LMM, the large multimodal, already reasoned that, okay, I don't need to look at the text, the image answers the question. So in this case, the multimodality eval actually shows that I am correct, right? So this is kind of an interesting example because we're looking at a visual question here in this example. So let's look at another one, right? The third one is, what is the first thing I have to do once my model shows up in the platform? And if you look at the output is a little weird. It says the first thing you have to do once your model shows up in the first one, it says Arize. I think that's because of transcription. That's supposed to be Arize. Doesn't matter. The first thing you have to do once your model shows up is to upload your data to upload data section. Well, that doesn't make sense, right? My model already showed up on my platform. Why do I have to go ahead and upload data again? So there's actually something going on here. So again, the output says that what we do is we check the evaluations again. And when you actually look at the evaluations, we can actually see that at the top, the text Q&A correctness and the text Q&A correctness says incorrect, right? So it actually says it's incorrect. It says faithful here, which is still interesting. So maybe the image I retrieved has something to do about uploading data or once my model shows up, but it did give an incorrect response, which my text eval actually found out, right? And if you actually look at the documents we retrieved, it has nothing to do with the question. The image might have, but again, it's not enough to answer this question. So at this point, I realized that there's something wrong in my application. I can improve it, right? I can do some specific changes to improve this application. So what I can do at that point is, at this point, I'm going to start my evaluation-driven development. And what I'm going to do is, I'm going to curate a data set of examples. So on the Phoenix interface, if you can pick all the examples and you can add that to a data set, you can create your own data set. It's completely up to you, but the goal is to create a data set of examples here. What you can also do is, you can also just filter on the hallucinated examples. So I'm going to, for example, filter on all the ones where the text hallucination equals hallucination. So you can write all these filters and add all of them to a specific data set to do your evaluation. So let's actually do that, right? I actually have a data set here that I created that actually has both good and bad examples that I want to improve on. So here I have my Arize multimodal data set, 20 examples of input, output, and the reference questions. And what I'm going to do today is, what I'm going to do right now is, I'm going to run experiments in order to improve, right? So what I did is I ran 4 experiments on this. The first one is the original one, where I used GPT-4o, and then I see that I have 85% faithfulness, 75% text factuality, and 75% text Q&A correctness. So this is where I started originally on my data set. So now what I did is I just tried to retrieve more chunks, right? I tried to change my retrieval strategy. And when I changed my retrieval strategy, it didn't change much, but my Q&A correctness went up by 5%, right? So it did some sort of improvement because I probably retrieved more chunks of the transcript and it made it a bit better. Now what I'm going to do is I'm going to switch the models. I switched from GPT-4o to GPT-4 Turbo, and the results were outstanding. My faithfulness jumped to 95%. My factuality jumped to 80%, and then my Q&A correction jumped to 85%. So I retrieved more chunks, and on top of that, I changed the model now, right? So, okay, this all looks good. Let me also try something else. Let me try to run a new prompt, right? So when I ran a new prompt, it didn't do that well. Maybe my original prompt was better, right? So in this case, I ran 4 experiments very quickly, and I saw that when I used GPT-4 Turbo, I did the best improvement on my application. And the cool thing is, what we can do on Phoenix is we can compare these experiments. So I'm going to compare the GPT-4 Turbo with my original experiment, which is GPT-4o. And you have side-by-side comparisons of 2 different models so that you can actually compare the different responses. So let's look at the last example I showed, right? What is the first thing I do when my model shows up on the platform? Let's take a look at this example. So when we look at this example, let me just go back here. So when we look at this example, we have GPT-4 Turbo answer and the GPT-4o answer. So if you look at the GPT-4o example, remember it said upload more data. But if you look at the GPT-4 Turbo example, it actually says that the first thing you should do is check the job status to ensure that your data has loaded successfully. Now, this is a much better answer instead of saying, oh, you need to upload more data once your data shows up in the file. Now it actually says, go and check the job status so that the data is ingested fine. So you can see actually the improvement here in terms of the response. And also you can see that my evaluations here on the right-hand side turn to 1, meaning my Q&A correctness is correct and my hallucination is not hallucinated. I am faithful right now. Where in my original example, it was incorrect all the way. So I can already see that the last example I showed, I was able to fix that by using experimentation on Arize. And what you can do is like you can also view the trace of each experiment. So I can already see like when I retrieve more images, more documents here, I can look at each trace of each experiment I got for each input and output. So that here I'm looking at task 3 as an example. And then I can go back and do all these different examples. So the goal here is again, create a data set, run different examples so that you can actually iteratively improve your LMM application. That's the main process here, and you can leverage something like Arize Phoenix in order to do and go through this specific workflow. So if I go back to this slide here, right? The evaluation-driven development. So that's kind of what I wanted to do. So we created a data set, we tracked our changes. I changed all my models, prompt, and retrievers. I evaluated them, and I found out that GPT-4 Turbo was the best experiment. So maybe I can confidently make that change and then go ahead with my life, right? So that was kind of what I wanted to show today. And then, first of all, thank you so much for listening. As I said, Arize Phoenix is open source. We now have a hosted version on llamatrace.com. If you want to check it out, leave us a star on GitHub. And then if you have any questions, please feel free to email me. And thanks so much for listening.